Welcome back to Cloud 42, I'm James. Last week we got started building a spindle lock for the G0704 mill. We got the first CNC operations done, and now we need to remove the top hats from the parts. Normally I would do this with soft jaws, but I have a different idea that I'd like to try today.
Okay, we have the parts milled out to this point, where we've milled away all of the material around and in the interior of the part. We've got it drilled, but it's still sitting on this plate of material that we use to hold it in the Talon grips in the vise, and we need to remove that. Now there's a couple of ways to do it. The normal method of doing this would be to put some aluminum soft jaws in the vise, mill out a contour in each jaw to hold the curved part here, flip it over, hold it that way, and then mill this off the back side. The biggest problem that we run into here, besides the fact that it's additional time, it's additional operations, additional wear on the end mills, risk of colliding with fixtures, it also consumes the soft jaws, and that's a consumable part that has to be either made or purchased. The other problem is that this particular part, if I just bear on the outside of this ring, it's going to distort it. And so I really need to have the jaw reach all the way up into these contours on the ears where we have a lot of support across the part for the forces to bear so that we don't push the thing out of round, which means that we really need to get the soft jaw up past this corner curve, almost to the halfway point in order to really contain this and keep it from spreading as we squeeze. And that would require a soft jaw that's 2 inches thick or more. And so I want to try something a little bit different. We already have a round contour on the inside, so I'm thinking, why not just hold that with inside jaws and the 3-jaw chuck in the lathe, and then just face this material off the backside? So that's what we're going to do. But since we're going to spin this thing in the lathe, this part's pretty symmetrical, so I'm not worried about that. But for this part, you can see that we've got a fairly large ear on this side with a lot of material in it. And if I hadn't added additional weight on this side with all of this extra material and just had enough for the clamp here, we'd end up with something really lopsided, so that when we grab it in the center here and spin it, we've got this big ear on one side. So what I did is I added material on this side to try to balance it out in the lathe. And Fusion makes that really easy because you can actually calculate where the center of mass of the part is and adjust based on that. So here's the original model, and let's take just the nose ring and isolate that. And look at this. Now, this was ultimately done based on a bunch of sketches, and let's roll it back to the point where it will be when we're spinning it in the lathe. This hole will not be in here, this slot will not be in here. And so I can just roll this back and look at it in the state it'll be in. We'll have milled it out. This slot will be in there, but nothing else. And what we want to do is adjust the size of this ear. Well, that ear is controlled by this dimension in this sketch. This line right here, this circle, and this offset of 0.52 inches is what determines the length of that. So we're going to want to adjust this dimension to center it up. So let me just change this to something smaller, like 0.48. And that actually makes this wing out here shorter. Now let's talk about how you figure out the center of mass. So you can go up here to Inspect, Center of Mass, select a body, OK, and it will put a marker here for the center of mass, and you can use that for measurements. So if I just go up here to Inspect and click on this inside cylindrical bore, we can see that the radius of this is 0.867. So if we have this thing perfectly centered, then this center of mass will be 867 thou off of this inside wall. So I've selected the inside wall, I'll select the center of mass, and you can see that it's not 867, it's 841, which means we need to add material on this side to move the center of mass out until that gets closer. So I can go back and edit this sketch. That's 0.48. Let's try 0.5. Makes it a little bit bigger, moves that out. Now we can go back and inspect this. Again, we're looking for 0.867. We're closer. 0.854. So let's move it a little bit more. And I fiddled with this. 0.52 is pretty close. And now when we go back and look at this, again, we're looking for 0.867. We're 0.866. You notice the dimension is flipped to the other side. So we've moved the center of mass 1 thou past the center. That is more than close enough. And we can go back, do our cam, machine this thing out, and we can have some confidence that when we chuck this up using this inside surface on the lathe with inside jaws on the 3-jaw chuck, this thing will spin and it'll be balanced when we're doing our lathe operations.
Okay, these are the parts, and you can see we've got them milled down to the waterline. We did that last time. And now we just need to remove the top hat. Now this is a lot of stick out, and I don't want that much material hanging out if I put this in the lathe and have all that spinning around. Especially as I start to cut through this and it gets thinner and thinner, we'll very rapidly reach a point where this material starts to get thin enough that it's very likely to bend and catch on the tool, and that's going to cause a lot of chaos, maybe even rip the thing out. So the first thing I want to do is take this over to the bandsaw and just take off as much of this excess material as I can. I'm actually having trouble seeing how much material is left here, so I'm going to put some, this stuff is just too shiny, so I'm going to put some blue painter's tape around it. And this will serve a couple of purposes. One, it'll allow me to see better, and the other is it will, if I do happen to bump up against the side of the part, it'll give me some warning and protect it from getting all scratched up. Even though this is just a tool and doesn't have to be beautiful, won't hurt anything if it is. Okay, let's try that again. Well, that took longer than I expected. Wood cutting bandsaw does not like aluminum. A lot of heat. Okay, let's get this mounted. We're just going to use the inside jaws. I don't care if the inside gets scratched up a little bit. It's not going to hurt anything because that part is going to be against the quill when it's in use. So I'll be the only one that knows. And you. You get this snug, but not too snug. I don't want to distort it too much. Just make sure we're tight. Give a little spin. Okay, that looks fine. Let's get a tool and take a test cut here and see how this goes. Make sure I'm clear. Okay. Okay, let's just take 10 thou, just again to make sure everything's working. Oh yeah, that's beautiful. Oh, I moved my camera here. Let me readjust this so you can see too. Okay, let's see how even we got the thing checked. Now just caliper dimensions on this are going to be fine. Within 1,000, not going to hurt anything. 737 and a half. $738, $738, $738.39, $737. Okay, I think we're pretty good here. $738 again. This is going to be good enough. Let's take it down to thickness. Now the thickness we actually want is 650, so I'm going to go ahead and set this to 650. Maybe. $650. Zero it. And so this means that we've got 90 thou to take off. And I want to take this nice and easy. Don't want to cause any real problems. Let's go ahead and take 30. Just see how that cut goes. Nice and easy, okay? Let's take another 30-ish. See where we are. So if we got 28 to go. And there we are. Nice and beautiful. Oh, that's actually quite nice. Okay, and where'd we get on thickness? Shooting for 650. Right on. Right on. Got some burrs, I think. Right on there. Okay, totally happy with that. So, turn the correct direction to take it out. Very, very nice. And the carbide in the mill does, or in the lathe, doesn't leave quite as nice a finish as the Superfly did. So that's one drawback to this method. Okay, let's do the other part. This chuck needs to be lubricated. Oh no! Oh, it's so close. Gotta get a little tighter. You very lightly touch this inside edge and just see if there's a burr that can come off. Because I measured this before and I thought this was going to fit. Oh, looks like no. Shoot. just see if there's any debris in here that could be blocking it. Well, looks like that's not going to work. Looks like I'm going to have to go over to the mill and do the soft jaws anyway. And that's okay. This part will fit just fine with the soft jaws. We've got plenty of meat to clamp on here, and the offset here is relatively small, so it should be pretty easy to do. That's too bad though. Okay, so I just need to deck the top of this off and bring this thing down to 600 thousandths. Is that the correct dimension? Yep, 600 thou. And to do that, we're going to need to make some soft jaws because this hole is just like a couple thou too small to fit over the inside jaws on my lathe. So I've got the soft jaws set up in here. This is a pair that's been used previously, so I'm going to have to knock this extra material off. I've got 1 1/8 inch parallel in between, which should be plenty to get a good grip on this without eating away too much of the soft jaw. First thing I need to do is just deck this down, take off the old soft jaw that I had on here. This was from the tool post grinder, motor clamp. So I've got the Superfly in here, and I'll just do this by hand and run back and forth and just knock this down. There's our soft jaws, nice and smooth. You can see the very faintest ripple in this side of what was there before, but that is going to be just fine because we're going to carve that away. And this end mill is our old friend that tries to pull out of the collet, so I'm going to torque it nice and tight. A quick little sanity check on the Z height. That looks right to me. Okay, let's carve out some soft jaws. Okay, so I didn't run an extra contour pass to dial in this outside diameter, and so I know it's oversized by a couple thou. And when I try to fit this in here, I can see that it rocks a little bit. I don't know if you can see that. So I'm going to go ahead and dial and take another 5 thousandths off of this inside because this is the same end mill, so I'm assuming I'm getting the same 2 thou or so. So if I take 5, it should make up for that difference. So I'm just going to go ahead and make a spring pass. Or actually not a spring pass, but a pass plus an additional 5 thousandths. And I anticipated this, so I already have the program ready. Okay, see if that's better. Oh yeah. Yeah, there's basically no rock at all there. Okay, it'll almost fit in there, but that's good. Let me go ahead and grab a vise handle. Take out the parallel and put in our part. You want to make sure the bottom of that is completely clean and the top of the part is completely clean, since that's how we're registering the height. This is good and tight because we're going to use the Superfly on it, and I don't want to yank it out. Oh, that's plenty tight. First strike, I heard it settle. I could hear it kind of clack against the bottom. Every strike since then has been nice and solid. So let me put the Superfly back in and let's deck this thing off. Okay, I think we're there. I did hear it trying to tear. And that's my understanding, is the Superfly really loves lifting parts. We are dead on the money, 600 thou. Let's check the other side and see how it is. Yep, maybe 2/10. Beautiful. Well, even though I had to make the soft jaws, I'm still very pleased with that result. So I've got the parts face to thickness and good to go. This one we actually did in soft jaws in the lathe, or excuse me, in the mill. So we could have just run a chamfer around the top edge of this, but I can't do that with this part because I didn't flip it over. And so even if I had chamfered one side of it, I would not have been able to chamfer the other side. I may have been able to put a chamfer on the inside here in the lathe because this was spinning, but I couldn't have done the outside of this. And so instead, I do want to chamfer these. These are a little sharp on the edge. So I'm going to use a router. And I know, woodworking tools, but I have them in the shop, so I might as well use it. This is a 45-degree chamfer bit that I have here in the router, in my router table. And I have this set up. It's got a guide bearing on it, and the height is there just enough that I can take maybe a 10 or 20 thou chamfer around the side. Now, if you've never used a router for this kind of thing, a router table before, the bit spins in this direction. And so what that means is, since the front of the bit is coming this way, I want to be moving the part this way, so I'm conventionally milling material off. If you try to go this way, there's a very good chance when you're trying to climb that the bit will bite in, grab, and pull, and it will actually throw the part this way. So I'll be conventionally milling this direction, which means that when I do the inside, I have to go the other way. But in fact, on this one, will I be able to reach the inside? Yes, I will. I've got to go exactly the opposite direction because I'm on the inside rather than the outside. Now, you'll also note, though, that I'll be holding this in such a way that if it does grab the part, it'll just rip it out of my hands and throw it that way and won't injure me or draw me into the cut. So this is probably going to be loud. I'm going to go ahead and spin up the router, and let's just put some chamfers on these. I like what I'm getting. And in case you've never used a router bit with a guide bearing like this, the guide bearing on the top serves two purposes. The first function is to simply guide the bit around the side of the part so that you get a consistent depth of cut. And the other function that this serves is to seize partway through your cut, spin, and ruin the outside of your part. Okay, those are the clamps. The edges are nice and soft. They're a little scratched up from being run around on the table here. That's one of the downsides of using the router. But overall, I'm happy. The last set of operations, we need to bore, drill, and counterbore and tap for clamping screws in both of these. And then we need to slit them with a slitting saw back over at the mill. Now, to get these into the mill held vertically is going to be a little bit of a trick, because I'd like that slit, I mean, I could just eyeball it, but I'd like that slit to be nice and horizontal. And of course, since we're going to be CNC milling this, having the stock in the position the mill expects it will be very useful. So these need to sit correctly in the mill vise. Now this one's not too hard to line up because it's got some horizontal surfaces that I can set this on, but this one's another matter. There are no horizontal surfaces, so to get this lined up vertically is going to be a little bit of a trick. If I'd use soft jaws, I could lay a soft jaw down and use that. That's the trick I used when I did the motor clamp for the tool post grinder. But for these, I'm going to need to do something else. I'm going to do some 3D printed fixtures that fit on the bottom and hold it, and cradle this in the mill, and that'll allow us to line this up. And we will continue working on that next time. If you're enjoying these videos, please give me a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.